Okay, I think we're going to get started. Welcome everyone to our Energy and Envelope webinar part 1. My name is Jennifer Christensen and I'm with Built Green Canada. Today is the first of 2 webinars we will be delivering on Energy and Envelope, with the second one to be delivered in September. Over the next hour or so, we will look at construction methods and types of products that contribute to lower energy consumption, as well as alternative heating and electrical systems and improved building envelope. We will also review benefits and provide practical, affordable suggestions for building better and to earn points towards Built Green Home certification. Just a few housekeeping notes, please. As Dave said, there were over 230 people that RSVP'd, and while not everyone has yet logged in, please mute unless you have a question. We have allocated time at the end for Q&A, and if you have further questions, please direct them our way to info@builtgreencanada.ca or call us toll-free 1-855-485-0920. We realize this webinar may run long, and we're sorry about this, and we'll try to keep things moving. For those of you who will be claiming CPD points, we're hoping to sort out the point value for this extra time with BC Housing. And finally, we also have a few giveaways at the end of the webinar, which Karen from our team will draw. Each are valued at about $400. In the coming weeks and months, we will be delivering other webinars focused on the key areas of our sustainable building program. So please watch for further invitations in your inbox. Again, the next one will be the second webinar for Energy and Envelope. From here, I'm pleased to pass this over to Dave Turnbull, who is the Director Emeritus and Technical Advisor to our board. Dave?
Thanks, Jennifer. Good afternoon, everyone, and welcome, and thanks for joining us. I'm going to do my best to manage getting people coming in and carrying on with this. So I do apologize if I do get distracted. I am easily distracted by bright, shiny objects. So today we're going to be talking about the energy and envelope section. When we decided to start doing this, I kind of figured this might be a really long topic, so we have broken it into 2, and we'll do these as we go along here. So with no further ado, let's get after it. So this section awards points for construction methods and types of products that contribute to lower energy consumption, as well as alternative heating and electrical systems. This, again, I'm just going to preface this with my little 2 cents worth of saying, you know, for a builder where some of the value is in the Built Green checklist, is using it as kind of a grocery list. Particularly when you're going through this, going through it with a client who might be somewhat a little more engaged in their sustainability bend. So it gives you an opportunity to say, listen, what do you think of this? What do you think of that? What do you think of the other thing? So as we go through here today, I'm going to kind of refrain from what I've done in the past ones, where we're going to go through the you know, we'll probably highlight some of the easy stuff as we go along, but I'm going to try to stick to basically throwing a little more color at some of the things that we have on the checklist here. So here's our presentation overview. We're going to talk about the house as a system, the benefits of improved energy performance. Those are pretty quick and easy. Then we're going to take a look into 2 sections of the first part, or the first section of our checklist, which is the energy section. So we're going to be going through, for those of you who have a checklist handy, we're going to be going through sections 1.3 and 1.5. And then the 1.1s, 1.2s, and the 1.4s we'll deal with at a later date. Okay. We're going to talk about some practical suggestions. We're going to talk about how we contribute and augment to the energy code, and the business case. We always like to throw that in at the end, the business case for third-party certified homes. By the time we're done, if you've attended all of these things, you're going to be able to do this on your own. We won't need to say anything. So, house is a system. Built Green is a holistic program. So our approach is that the home is a sum of its parts. They're all interconnected. Everything we do, everything from site orientation, building materials, HVAC equipment, windows, etc. And the big thing that we like to push is that the energy performance requirements increase without consideration of the other sustainable components. We kind of miss we can kind of miss the boat. We tend to become, as a society, we tend to become a little myopic on whatever happens to be the crisis of the day. Back in the late 80s and early 90s, it was the ozone layer. So what we did is we had the Montreal Protocol, created a whole bunch of things that were actually they didn't damage the ozone layer, but they contributed crazily towards the greenhouse gas problems that we're having right now. We will want to look at things in a more holistic manner, and that's kind of where our program is based out of. So the benefits of improved energy performance and envelope, we have a reduction in operating costs and utility bills. That's kind of expected. There is a 15% automatic premium mortgage insurance through Genworth, CMHC, Canada Guarantee. They all have this premium insurance for all Built Green products, regardless of the level that you qualify at. We have improved climate control and protection of the indoor environment with reduced stress. We have a more comfortable home, fewer drafts and sound reduction from outside, less wear and tear on mechanical systems, and a reduction, of course, in greenhouse gas emissions. So the energy and envelope, energy efficiency offers opportunities to save money and reduce greenhouse gases, which is kind of the order of the day right now. An initial investment that homeowners can often recover. You can go, there is a diminishing return as you go further and further down the list of things, and you get further into energy efficiency. But at some point in time, the codes are just going to catch up to it. So some people, even though they may not get a really good positive return on it, their return might be in the sense that when they go to resell their home in a period of time, maybe it's 10 to 15 years from now, once the building codes have actually progressed, then all of a sudden their homes can actually perform very comparably to homes being built in that time period. I used to work for a home builder, and we did a lot of energy efficient, high performance homes. And most of the homes that we built would perform very well and will continue to perform very well comparatively to homes built probably 8 to 10 years from now, easily, maybe 15 years from now. So there is that. If somebody's looking at selling a home and it performs much better, there is something where eventually energy, I believe, will come into the conversation. The building envelope, the separation of interior and exterior of the home, it helps facilitate the climate control and protect the indoor environment, and is responsible for the significant amount of energy consumption. So these two elements are critical in a well-constructed, tightly sealed thermal building envelope, and require controlled ventilation. Now, we talked about ventilation in our last session, which was great. Properly sized, high-efficiency heating and cooling systems. We're going to delve into that a little bit today. Energy-efficient doors, windows, and appliances. That's going to be in a subsequent session. So energy and envelope, a closer look. You can see here, these are the different sections that we have even within the energy and envelope section. So we deal with energy modeling, the building envelope, mechanical systems, which is what we're going to talk about today, appliances, on-site generation, which is what we're talking about today, and lighting and automation. So let's get into it here. So I kind of want to take a little bit of a departure from, like I said, from how we've normally done this. This section 1.0, this has to be filled out regardless. And for most single family home builders, this is going to be where most of your points are going to come from. It's the difference between your home, the EnerGuide rating as built, and the EnerGuide rating reference house. Or for our friends in BC, or if you're in Alberta and your EA is familiar with the BC step code, you can also qualify on the step code. So what this is you put in your as-built reference, as-built rating from your EnerGuide label and your reference house from your EnerGuide label. We take out the electricity on it, so you actually do perform generally a little bit better, and that's how we assign you the points. And it also has bearing on what level of built green you can get up to. So we still have, although you can get more points in the section below, particularly if you're going along the roads of, if you're a builder that goes along the lines of home automation, and that sort of home automation, you throw in a lot of appliances, really good high-end energy efficient appliances and stuff. You might actually be able to get a few more points in this section than you would just putting into this part here. But like I say, for most builders, I would say of the builders that I deal with, all of them actually just deal with this first section here. They wouldn't get more points going into the other ones. But let's have a look at the other one. And then, oh yeah, sorry. As we go along here, energy modeling, the EnerGuide we can use, or we can use the BC Energy Step Code. So this will allow for our friends in BC, even though your EnerGuide may not work necessarily. We just had one today where the EnerGuide didn't quite work out, but that was because they had gone from a condensing hot water tank to a condensing tankless system, which is actually an improvement in the overall energy profile of the home. But because the EnerGuide uses a different comparator for a hot water tank versus a tankless, they didn't get, the builder didn't get the full value. So they have a really good energy advisor. Their energy advisor saw this and said, well, on the building BC Energy Step Code, we can use the mechanical energy use intensity, and we can still qualify this at a step 3, which is which will give us a built green gold. So if we have some EAs on there, this is another way for you to qualify your clients on the built greens in the built green system. Okay, energy modeling. So you can choose your compliance pathway using either the step code or the compliance requirement for built green, which is the EnerGuide. The bronze certification, that's a home built to code. And one of the points I like to make with this is people say, well, it's just a code built home, but it isn't. When we do the certification, the bronze certification, that means you've built the energy to the energy efficiency of the day, but you've also done a lot of the other sustainable things. You've done stuff in materials and methods, the ventilation, the indoor air quality. These are all things that go above and beyond what a code built house would be, which is why we allow that to come in at the bronze certification. With a silver certification, a step 2 BC building BC step code, or a 10% lower than the reference house. Gold certification is step 3 or 20%, and platinum a step 4 or step 5, or the house rating 30% lower than the reference house. Now, as step codes come in nationally, we will probably see this kind of thing coming in as well for the rest of the country. Greenhouse gas calculator. This is a new item that we've done for this year. We're also giving points for checklist 1.1.1. And what it is we can give you points based on your greenhouse gas reductions. So what we've done, there's a separate page in your spreadsheet there. So you just click onto it, and you can put in your province. You put in the quantity from your EnerGuide rating, the quantity of natural gas, the quantity of electricity for the as-built. Same thing for your reference home, and then what it'll do is it'll give you your total greenhouse gas reductions as a percentage. You can put that onto the spreadsheet and get points for it. And it is province specific. For our friends in BC, where electricity has almost no carbon footprint, the electricity has no carbon footprint. For our friends in Alberta, Saskatchewan, that are coal-fired, the electricity has a much higher. Ontario, Manitoba, again, much lower. And as we go out into the Atlantic provinces, again, it's a little bit higher, a little bit lower, depending on where you're at. Mechanical systems. So like I say, in this one, we're kind of skipping over 1.1 and 1.2. We're just going to go to 1.3 mechanical systems, which is kind of a lot of what, in my practice, it's a lot of what I deal with. So mechanical systems become vitally important and directly impact the efficiency of the home. They provide healthy and comfortable environment, again, in combination with the ventilation system. So in this section, what we're looking at is all the possible mechanical systems. Designing. This one's becoming more and more important. I have a friend whose company I work with here. He has a system, and what his adage is, you know, we don't build homes the way we did 50 years ago. Why are we trying to heat them the same way we did 50 years ago? And it makes absolute sense. So we're talking, you know, we are starting to get into design, right sizing the equipment, right sizing the ducting, radiators, and that'll work to ensure the correct amount of heating is going into the rooms of the home. And we're not going to delve into this too much into the weeds today. I think this is something that I might do just as a separate item, and we'll show the builders how they can actually use the modeling that they get from their EAs to work on some of this design stuff. So let's get right into it. Mechanical systems, section 1.3. The points. All mechanical system is placed above grade in the home to prevent damage from potential flooding. In the previous webinars that we've done, we've mentioned that we've started to put in disaster preparedness into our program, and this is one of the items. So typically, what we'll see in a home, this is a typical installation. You see, we're sitting in a concrete floor in a basement, or you know, if somebody's building slab on grade. So in areas that are prone to flooding or prone to water, this is not always the best way, because again, if the basement gets flooded or you get flooded, you know, you can, one, damage some very expensive appliances, and two, take away your ability to heat or cool the home or to get hot water. We do recommend, we do give points for going up and putting your mechanical systems either on the main floor or in the second floor. I have a client out in Ontario that I work with, and they started putting their mechanical systems on a second floor, and it actually opened up some really interesting ways for them to run their mechanical. And again, it's not something I'm going to get into the weeds for, but it actually opened up some really cool ways for them to do this, and it actually saved them a little bit of money in doing it, in terms of having a really good return air system, in terms of having a really good duct design. This was a fantastic way to go, and they went with a product that actually fit in a closet. So if you can picture a 2-foot by 2-foot closet, and that had your mechanical system in it. It had your tankless water heater, and it had your heating system. So next one is installing a zone heating system, either from a single HVAC source, or using 2 or more programmable thermostatically controlled zones, or separating separate systems through separate programmable thermostats. And we give extra points for extra zones. Now, there's a number of different ways. We're going to jump down a bit of a rabbit hole here. If anybody's interested, this will be available. So this, you'll probably be able to click on this link later and get access to the zoning decision guide for builders. LEAP, which is local energy local energy efficiency partnerships. This team has been actually putting together some really good mechanical stuff lately. So the zoning decision builders guide is one of them. They also have one for a duct design that they've just put out. There's some really good knowledge there. So the following slides kind of come from that. So with the zoning system, one of the things with zoning that it does is it does help alleviate the stratification in a single zone home. This picture here, I swear this could have been my house. My basement is a little cooler. My main floor is just right, and my upstairs swelters. And I have a single stage, single zone system. Now, if I was to make this, you know, a multi-zone system, in my particular house, I would probably do a 3-zone system. So you have a basement, main floor, and upstairs. And you can see up in this top corner here, you can see how they accomplish that. So coming off of your furnace, you have 3 different systems. These are all set up with different ways of getting the air to the different places. So there's a number of different ways you can do this. Like you can do, in a three level home, zone 1, 2, 3, 1, 2, 3, 4. If you're talking 3 levels above, you can combine zones in different ways, and you can actually do zones, 2 zones on 1 floor if you like. So it kind of depends all on what you want to do and how the home is going to operate. And as we get further and further into into energy efficient home and a little more into the smart homes and things like that, we are going to be seeing that. People are going to be looking for that sort of thing. It's like, well, the basement, we're not in it very much, so why are we heating it as much as we do? You know what? We're only in the bedrooms at night. Why are we heating them during the day? I spend most of my time in the main floor, so that's where we want the heat. So it's going to give clients the ability to actually heat where they're going to be. And I think that's going to be something, apart from energy efficiency, the next thing is going to be all about comfort. And this is a great way to do it. So for zoning systems, we can do a zoning system with forced air. Electric baseboard is a easy way to do it in some areas. Radiant baseboard using either a glycol or a water-based system, or radiant floor heating from the floor, from the ceiling. So let's have a look at these different systems. We're going to look at the forced air stuff first. Factory integrated zone system. So this is a zone system that actually has the zoning built right into the module. So you can see at the bottom here, you have dampers. These actuate, they turn on and off. These things usually have, in terms of motors, they usually have either an ECM motor or electronically commutated motor, or a variable frequency drive motor, which ramps up and ramps down as the amount of air is required. As those zones open, more air is required. The fan amps up. The second one is a site assembled zone system. So that was very similar to the first slide I showed you. And this one here, what we have is we have a site installed zoning control center. And this one may or may not have a variable frequency drive or an ECM motor. Sometimes these things just do have a single stage motor, in which case there will also be a fourth item coming off of there, which is a dump. Which dumps it back in, dumps things back into the system. And then we have a zoned ready system, and this is something that I have a couple of builders here that are starting to do this. While the zone system can cost you an awful lot of money, the controllers, the mechanics, like for up on that second one here, those controllers, that could run you a few $1,000s, but to actually have it zoned ready is just a little bit of extra heating. And actually overall, the home will perform a little bit better. It won't be as well as if it were zoned, but it will perform a little bit better. So we can actually do a zoned ready system. And I have, like I say, I have a couple of builders that are doing that right now, because their clients maybe don't want to put a zone system in right away, but maybe they want to put in something later. And for the one fellow, the particular system that he put in, it wound up costing him to do zoned ready. I think it was only like a couple of $100. And this, now I have to qualify this. This was on a smaller townhome style product. Larger homes, of course, are going to require a lot more ducting. Okay, one of the other ways, and one of the other ways we can do it is from a mini split system. So for those of you that are using air source heat pumps or something like that, this is a mini split system. So we have an outside compressor, air source heat pump, and then you have a couple of different heads. So again, this is a way that you can just put heat where you want it. The great thing about this is you can have zones by room if you so chose. Now, one of the other things is the electric radiant baseboard. And again, this is another great way of doing this just by zone. Now, when we're talking about electrical and natural gas and things like that, one of the things that we have to be aware of as builders and designers is we should be aware of the input cost of the fuel that we're using. in the province where I'm at, which is Alberta, the cost of natural gas is about 1/8 the cost per heating unit of electricity. So heating with electricity is not the best idea. I've been to areas in BC where the cost of natural gas is actually almost on par. And when you put in the standby charges for natural gas, it's actually a little bit higher. So heating with electricity is a good economic idea. So it's just something that as builders we need to keep an eye on. We don't want to be putting in something that's actually, might be more energy efficient, but at the end of the day costs the consumer more money. It won't win us any friends. Radiant heat systems in the hydronics world. I always love these. These to me look like they should be on the Starship Enterprise. You've got lots of valves. You've got lots of, this one here looks like she's got 3 zones, judging from the 3 pumps running off of a boiler system. And here we go into the coil in-floor systems. There's also radiant systems that go into your ceiling too. So depending on where you're going and what you're doing, pick the one that's right for you, and talk to your mechanical guy about it. He'll give you the good directions. Installing a high efficiency sealed combustion heating appliance. Now this one here is kind of a no-brainer. We are going to see a change in this, just so that everybody's aware. The National Building Code is looking at changing the baseline in their building code from a 92% efficiency furnace to a 95% efficiency furnace. So when that happens, which I don't know, it might happen sometime next year, who knows, we will probably see this go away, where the 95 will be the baseline, and we'll be looking at 96 and 98 as the upgrades. But again, it comes straight off of the Energuide rating. So this one here is one that one of my builders uses. This is this particular one has a variable speed motor, and it's 96.5% efficient. So it's, and this is fairly common for this area. The next one is installing heat pumps to supply a majority of the space heating. So we're looking at a ground or a water, one with a COP of 4 or better, or a SEER of 15, or an air source heat pump with a split system of 8.5 heating season performance factor and a minimum SEER of 15, or a single package system, which is the single package works very similar to your furnace, except it's like it has a unit outside and a unit inside with an air handler and a coil. And for those ones, we're looking for a heating season performance factor of 8.2. So when we get into heat pumps, there's a couple of different types that we can deal with. Electric is the most common, but there is a natural gas heat pump, and we'll look at both. And there's 3 source types. There's the geo-exchange. Some people call them geothermal. And there's a water, which is very similar to a geo-exchange. And then there's an air source heat pump. So let's have a look at these guys here. So geo-exchange uses a naturally occurring heat in the ground at depth as the heat source. Now, depending on where you live in Canada, sometimes you have to go a little bit further down to get the warmth. Sometimes you don't, and the costs vary wildly on this, depending on how deep you go and the type of ground you're digging in. If you're digging in ground that is nice and sandy and a little bit of clay, that's all great. But if you're building, if our friends that live anywhere near the Canadian Shield, blasting into rock is probably a very costly way to do a system. So you just kind of have to gauge that by the kind of soils you are, and talk to some of the specialists in the area. The technology, though, is tried and true. It's bulletproof. It works really, really well, and it can, properly done, it can actually work for a long, long time. It has a very long lifespan. Air source heat pump. This is a little bit newer technology. It uses the heat in the air as the heat source. So people don't realize this. And for those of you that are not from the prairies or the northern parts of Canada, and we say minus 30 Celsius, there is still heat in minus 30 degrees Celsius. It's a matter of extracting that heat. So even at minus 20, there's still heat in the air. Minus 30, there's heat in the air. Anything above minus 273 degrees Celsius, there's heat. The technology is a lot better than it used to be. The air source heat pumps, they kind of came into Canada here probably 10, 12 years ago, maybe a little bit longer. They weren't as bulletproof as they are now. They're actually very, very well constructed, and there's some really good ones. Even for people that live in northern climes, there is a cold climate air source heat pump. There's a few manufacturers of that now. So this technology, especially if you're building towards net zero, these two, the GeoExchange and the air source, are the two technologies you want to look at. Water, like I say, it's rarely used unless you have a large body of water nearby. It's similar to GeoExchange. What is it, in Ontario, in Toronto, there's actually buildings downtown that actually run lines into Lake Ontario, and they use that as their cooling. So they're actually using that as it's a kind of GeoExchange, which is a fantastic way of doing it. So this is just kind of a little slide, lets you know how geothermal works. It's kind of what we call the Earth's energy balance. So where does it come from? So 47% of the sun's energy gets absorbed by the ground, and that comes directly into the ground, and that heats it up at depth, and it works its way further into the ground. Now, the other thing that is great with air source heat pumps is that with the ground source heat pumps is that you can, or any heat pump, you can run them backwards for air conditioning. So you can run them for heating, you can run them for air conditioning. With the GeoExchange, when you run them for air conditioning, that puts heat from your home back into the ground. So it actually improves the efficiency of your GeoExchange system. So it's a great way to do it. If anybody wants to see one of these kind of systems on steroids, you can Google a project called Drake Landing. It's in Okotoks, Alberta. These guys use solar thermal. They put it into a giant piece of land. It's like a giant reservoir, giant battery, and then they pull the heat from it in the winter. It's a fantastic project. So when we're getting into ground loops and into the GeoExchange stuff, there's a couple of different ways you can do it. You can do it with a horizontal. So if you have the kind of, you don't have an awful lot of, you're in a more southern climb, our friends in the lower mainland can probably get away with this. Friends in southern Ontario can probably do the same. You can do what's called a horizontal loop, and these things are a little bit less expensive. You're not drilling as much. And these work really well in absorbing. For people that are a little bit further north, we have to go a little bit deeper, so we do a vertical one. So you can see how this one goes, and it's just one continuous loop of piping, but it just picks up heat as it goes down. And some of these things go down, in our neck of the woods here in Edmonton. We're going down 50 plus feet. To get to be able to run these things properly. The other one is the air source heat pump. So again, we have an outside source or outside ambient air, and we're pulling the heat from that. We're running it through a compressor. It's basically any heat pump is an air conditioner that runs backwards. It works off of the expansion and contraction of gases and liquids. So as something expands, it comes under pressure. The temperature goes up. It expands, and you can get the heat off of it. And then we can go through an expansion valve, and the pressure reduces. It cools off, and it can go to the outside. And then we work it backwards for the cooling season. So this is a Zuba Mitsubishi. This is one of the cold climate air source heat pump units. So even in areas like Edmonton, northern Alberta, northern BC, northern Ontario, in the northern areas, these things run right down. You get a higher coefficient of performance. You get a higher coefficient of performance, greater than 1, which is a 1-for-1. So you can get 1.1 down to minus 25, minus 30 degrees Celsius. So these things work quite a ways down, so that you are actually saving energy as you go along, except on the really coldest days, in which case these things will actually have an electric coil as a backup. Now, electricity is the most common one. Gas air source heat pumps are coming up. These are also called adsorption, and they use ammonia and water instead of they use it instead of a hydrocarbon refrigerant. So in terms of environment, the production of it and stuff like that, the ammonia and water is a little bit better than what the HFCs are going to be. But again, the technology, it's primarily commercial and multifamily. Right now, single family is coming, though. It's widely available in Europe, so they're keep an eye out for it. I imagine in the next few years, as we start moving down this road, we'll start seeing it. So this is how these things work. These things actually have a gas engine, and in a lot of cases, they'll run on natural gas. So they run a natural gas engine that runs the heat pump compressor, and you can have air output, water output. It'll heat water and stuff like that as well. So, and again, it works the same as your air source, as your ground source. It takes the heat, compresses the heat, and allows that heat to be distributed. And then if we want to run it in air conditioning mode, we just run it the other way. We pull the heat from the coil, and we put it to the outside. So efficiencies, I've thrown a lot of terms out here, so I just kind of wanted to let people know what these all mean. So COP, coefficient of performance, how many units? It's how many units of heat per unit of input. So it's how many kilowatts of heat do you get per kilowatt of input, and that's usually a ratio of 1 to 1, 2 to 1, 3 to 1, 4 to 1, 5 to 1, that sort of thing. SEER is a seasonal energy efficiency rating. It's a total number of cooling BTUs per season, so what they would use in the whole season divided by the watts, or the watt hours used in a season. And again, these tend to be numbers more along the air conditioning units. You'll see these, and these will run anywhere from a 10 to, well, I think you can get SEERs now in the low 20s. The next one is HSPF, which is what's very common for air source heat pumps. Heating season performance factor is the total number of heating season BTUs divided the total number of watts put in. And in all cases, the higher number is better. So we want to make sure that we want to, if we're going for the most efficient product, and usually for most of these things, efficient is a way to go. It's a in for a penny, in for a pound kind of a thing. It's not a whole lot more money to get the really good stuff, and you're already paying. In a lot of cases, you're paying thousands of dollars more for this. Pay an extra $1,000 and really get the efficient one. Installing a programmable thermostat. Let's see here. Oh, we got a few comments here. Most homes must have an open plan. Most homes have an open plan. How zoning will be beneficial for main floor and second floor. I'll deal with that at the end because that is a very long explanation. Can you comment on the current state of availability of air to water heat pumps in Canada? Well, there's a couple of different ways that you can do it. You can run air to water through what's called the desuperheater through your GeoExchange. And we are going to talk about air to water when we talk about the hot water tanks. So stay tuned. And that's Jameson. And Cliff is disturbed by the prominence of natural gas still has in our heating and hot water systems. Yes, but it's here for a bit, and it's still better in some jurisdictions, i.e. Alberta, Saskatchewan, the Atlantic provinces. Natural gas is better than heating with electricity because they burn coal in those areas. And the coal has a pretty much, it's a 1 kilogram per kilowatt is pretty much the ratio. So natural gas actually has a much lower greenhouse gas emissions. So while it's not the preferred thing, we still have a lot of greening up to do on our electrical grid to make it universally acceptable. Now, that is, I have to say, that is solar notwithstanding. All right, carrying on as if we were normal. Sorry about that. Installing a programmable thermostat with a setback and continuous fan for 1 point, or a programmable thermostat with Wi-Fi that can be controlled by a smartphone for 2 points, or one that is learning capable for 3 points. Well, we all know what those ones are. So that's these guys here. The top left is your standard one. These pretty much they all have a fan schedule. Many of them will get you double points in the air quality one, because a lot of them do have a timer for replacing the pleated air filter. The next one is your Ecobees. These ones are Wi-Fi compatible. And I just threw an Ecobee up there. Honeywell has them, White Rogers has them, everybody has them that are Wi-Fi. And then in the bottom right hand there, we have products like the Nest that are learning capable. So what these have is they have a logic circuit put into them. So they learn your movements, when you come home, when you're not home, and they do it on a I think they do it on a 365-day calendar. So it's quite a sophisticated piece of technology. You know, as long as you have habits, they're a great product to work with. Installing an HVAC appliance with a variable speed fan. Now, I talked about that a little bit when we were talking about zoning. That is a brushless DC electronically commutated motors. We also accept what they call a variable frequency drive. Those are they're low voltage. They use about a third of the electricity that your standard passive split capacitor does. And pretty much all motors now have to be ECMs. But what we're looking for is the variable speed ones. The multi-speed ECMs still do pull a little bit more wattage than what the variable speeds do. And then all mechanical systems are designed through a certified mechanical designer. This is something that is near and dear to my heart. I work with a group of mechanical designers on a national level, and we're trying to get this kind of out there. Again, we don't build homes the way we used to. We shouldn't be heating the homes the way we used to. I do, in my work, I get an inordinate amount of calls from people that have cold rooms, that have hot rooms, that have, all these different things going on. And usually when they come to me, they want me to go in, do a blower door test. They want me to go in with a thermal camera because they think there's insulation missing. The fact of the matter is 99, I'd go 98% of them. It has nothing to do with the insulation. I've had one or two where it did, but the rest of them were all based on the mechanical systems. The air was not getting to where it needed to be. So what it is, we got to look at different systems, and we got to look at mechanical designers. These are our friends. These guys here, again, I've turned a few of the builders in my area onto some. And if you're ever looking for one, HRAI, Heating, Refrigeration, and Air Conditioning Institute, they'll have a list of certified designers on their website. So they will design. These guys can design both your domestic hot water systems, or if you're doing radiant heating systems, they'll do those for you, or they'll do your forced air systems. And you'll be surprised in terms of the sizing of the system. In most cases, rented lips. In most cases, builders put in furnaces that are at least one, in a lot of cases, two sizes too big. So this costs people money on two sides. One is it costs you extra money for the bigger furnace. And secondly, it costs you money because that furnace is short cycling. It never gets up to full temperature, so it never hits its full efficiency. So again, I think we'll do a separate one just on this. We'll probably do it in conjunction with LEAP, because again, through that group, we've done an awful lot of work nationally on it. Okay, water heating systems. When we're talking about air to water systems, here we are. we have a number of different ways that you can get points in there. Installing a sealed combustion direct vents 2-pipe system, or a condensing domestic hot water tank system. So that's 2 or 3 points. And again, these are higher efficiency systems than what we used to be. The 2-pipe system is pretty much stock in trade now. But the condensing is kind of the new thing, and we're going to get into that a little bit. Installing an Energy Star rated tankless, so that's something with Energy Star rated with an energy factor. Now, what an energy factor is it's the thermal energy, the thermal efficiency, less the standby losses. So in terms of a tankless, there's not a lot of standby losses. There's a couple that have small reserve tanks on them, so they do have a little bit of standby loss. There's actually one out there now that I've seen. It's actually a tankless system that has a 5-gallon reserve, which is kind of cool, but it'll have a lower energy factor simply because it has that storage loss. Get it better than 0.8, which is a non-condensing unit. For 2 points, higher than a 90, which is a condensing unit, for 3 points. Installing a high efficiency boiler system for your domestic hot water. Now, a lot of people think that tankless and a boiler system are the same thing. They're not. We're going to talk a little bit about that. The next, or we install a heat pump. You notice all of these are ors, right? We can't, if you install a, let's say you have a boiler for some radiant heat, and for some reason your plumber installs a combustion direct vent 2-pipe, you can't take points for both. You got to take points for whichever one is best for you. So the next one is installing a heat pump based domestic hot water system. These are a little bit new in terms of technology. Some are good, and I've used them when I was a builder. Some we used them and they weren't so good. So we're just gonna stick to what the good ones are. It can be groundwater or air sourced with an energy factor of 1.5. So that means for every kilowatt of energy you put in, you get 1.5 kilowatts of heat out. Energy factor of 2 for 2 points. To supply a minimum of 35% of the peak domestic hot water load. And 70% of the total domestic hot water energy load. And then finally, install a high efficiency electrical domestic hot water system with a standby loss 5% better than NECB, and we'll talk about that in a little bit. So let's talk about the hot water tanks. This is what used to be common. This is an atmospherically vented unit. This is very common up until the building code changes around 2005, 2007, when we all of a sudden we had to go to a non-open combustion appliances. But for those of us that are on the line that are doing renovations and things like that, this is a very common thing that we see. These things have a couple of problems with them. One is that they're horribly inefficient. The very best of these will have an energy factor, which is the efficiency plus standby losses. They'll be about a 0.62, which means 62% of the energy that goes in actually winds up maintaining the heating and maintaining the heat of the water. But the other side to this is these are also very susceptible to combustion spillage. So if a client has one of these in their home and you're renovating a kitchen and you just put in a small jet engine for a range hood, when that thing fires up, it's going to suck all the products of combustion back into the home, and we're going to have carbon monoxide in the environment. So we really like to get away from those things if we can. So in 2005 to 2007, depending on where you were in the country, we came up with the induced venting. So what this had was this still used open combustion, but we had a 1-pipe system where there was a fan on there, so when it was running, the fan would actually pressurize it and move the gases out. This was a nice little middle step, but where we really wanted to be was this guy here, and you can see up on the top there's 2 pipes, okay? And what that is that brings your combustion air in and your venting gases out. So there's absolutely no interaction with the home environment with this. This is the safest one for everybody to use. So when I'm talking to clients on a retrofit basis, I always tell them sealed combustion is the way to go. It's a safety thing. For those of us that are builders, if you have a client that's living in an existing home, ask them about that. Say, listen, you know, we're using sealed combustion now. What do you got? It's another way to make them feel better about buying a newer home. Condensing hot water tanks. Now, many claim a high thermal performance. These things are usually 95, 96% efficient on the thermal efficiency. But what really matters with these is how they're insulated. So when you're looking for one, you want to have one that's insulated to at least an R12.5. The more insulation, the better. An R12.5 is usually 2 inches of a high density polyurethane. Many have inputs over 75,000 BTUs, so they don't have to have an energy factor rating. They're considered a commercial in nature. But again, your EA can actually calculate these things out. Now, the difference between these, and I'll show a little diagram of a traditional hot water tank in a second here, but your traditional hot water tank, there's just a chimney, there's a burner on the bottom, it heats, and you can see we have the burner on the bottom here. But what happens is the gases in this now come straight up, across, and they circulate down. So the gases take a much longer time in the water, and the gases give off and they have more time to give off their energy to the heating water. So these things here tend to have a much higher energy efficiency. I personally am a much bigger fan of tanklesses, but for those builders that are building homes and the clients want to have what I call a small car wash, where they've got body sprays aplenty, and as soon as they fire those things up, they got no skin left. A tankless isn't going to keep up with something like that. You know, you can get one of these things, 75,000 BTU inputs. You can get these things in sizes up to 80 gallon. So they can actually handle that sort of thing, and at least you're doing it efficiently. Condensing and non-condensing tanklesses. I apologize for the blurriness of this. My source did not have that high resolution. So tankless systems, they come in non-condensing and condensing versions. The big difference is where the burners are. Condensing usually has a downdraft burner, non-condensing an updraft burner. Non-condensing will have efficiencies in the 80 to 85%. Condensing is usually 90 and above. Condensing by nature is 90 and above. Most of them now, they're 95. We don't see a whole lot of non-condensing product on the market. Okay, boilers. So boilers heating domestic hot water. So again, we're just talking about, in this section, we're just talking about boilers heating hot water. We did have, in the other mechanical section, we did have a high efficiency sealed combustion heating appliance in 1.33, which your boiler, if it's supplying an air handler or if it's supplying a radiant floor system, it qualifies for that as well. So boiler can get you a couple of points here. So again, with the boiler, we're using what's called an indirect hot water tank. So there's no actual flame in this thing. Now these things are great in the sense that they actually last a little bit longer than your traditional hot water tank. They also take a little bit longer to heat up. There's the downside to them. So what we have is, coming off of the boiler, we have a pump. It brings the warm or hot water in, and it gives up its heat to the hot water tank. And what this does is, these things use the natural buoyancy of a fluid. So it's the same as the buoyancy of air. Hot air rises, hot water rises as well. So in a tank, the coldest water is always going to be at the bottom. Now I want you all to remember that, because when we start having a conversation about electric hot water tanks, that is going to become very important. But in this case, we're talking about an indirect tank, so the heating element is in the bottom of it. So that's where the coldest water is. It's going to go up and it's going to heat. And this is a great way to do it. So when we're calculating this, although your boiler may be 95% efficient, you're going to lose a little bit because you're putting it into a storage tank. The storage tank is going to have standby losses because it's going to be sitting there. So again, if you're going for something like that, get something that is, you know, over insulated. Again, 2 inches of high density polyurethane is kind of the minimum, but there are units out there with 3 inches, which are fantastic, and they have they have 50% less heat loss, so they actually work much better. And here's a picture of one in the real world. Again, looks a little confusing to the lay person, but this one here is your you've got your hot water, indirect hot water tank, and it looks like you've got a 4-zone heating system for the home. So again, going back, your mechanical designers that we talked about in the previous section, they're gonna be the guys that can also help you with this sort of thing. Okay, heat pump, hot water heater. Okay, now these things are a relatively new thing. They've been out now for, I want to say, about 7 years. There's good ones and bad ones, so you do have to be a little bit careful. The pictures that I've used here are just generic. So as an EA, I'm not allowed to promote any product. If there's a product in here that's shown, then it's just by accident, and I apologize for that. So a heat pump, again, it works very similar to your air source heat pump from the outside. Now, one of the knocks on this is that it does take air from the inside, and it cools the air inside. So when the EAs, as an EA, when you're doing this, we have to make sure that we're making up for it in terms of the heat makeup that we have to give it. But these things work really, really well. If you're going into net zero, or if you're in an area where electricity is your only option, this is a great way to save. These things here, overall, they tend to have really good. The one on the left there has a what they call an EF of 2.2. So so for every kilowatt of electricity that goes into it, you get 2 kilowatts of heat. So basically, it cuts the heating cost of your hot water in half. So there's actually a really good way to reduce the overall energy profile. So there's a couple of different ones here, and they work very similarly to the other ones, where we've got a coil in the bottom, and it's working on the natural buoyancy of water, and it heats from the bottom up. Again, in a geo exchange system, we can run through what's called a desuperheater, and you can actually run off of your geo exchange system. You can run into an indirect tank as well. Now, here's what I promised you: difference between an electric hot water heater and a gas hot water heater. So when we were talking about the condensing one, I'd just like to draw your attention to the diagram on the right. This is your standard gas water heater, where everything just goes up a flue. In the case of the other ones that are sealed combustion, it still goes up a flue. The flue is just sealed. Now with the condensing, it wrapped around a few times. Now if you look over at the electric hot water heater, you can see here that we have elements in the middle. We have an element at the bottom and an element at the top. Again, we're trying to heat from the bottom up. With electric hot water heaters, and I'm going to caution again, because we talked about natural gas versus electricity in the beginning, how to raise the ire of somebody, which is okay. It's okay to have that good discussion. So with electricity, again, your cost, at least in my market and in many markets, the cost of electricity is anywhere between 6 and 8 times the cost of natural gas. So you're looking at really increasing somebody's electrical bills, even though on paper you're technically saving energy. Because an electric hot water heater, they're way more efficient than a standard gas hot water heater. So now what I call your attention to is at the bottom, we have a heater, we have an electric heating coil, but you can see beneath there's still a space. And what we found, and for my friends in Ontario, they're going to know this already, because this is actually in your code. It hasn't crept into the rest of the country yet. So with electric hot water heaters, what they found in Ontario is that you actually have to keep an electric hot water tank hotter than a normal tank. So the minimum that they keep it in Ontario, I think, is 130 degrees Fahrenheit. Where typically here we tend to keep them about 120. And the reason for that is to keep bacteria from growing at the bottom of the tank. Legionella will grow in anything under 125 degrees Fahrenheit. So it is entirely possible for Legionella bacteria to grow down at the bottom here. So in Ontario, what they've done is they have said that you have to keep your hot water tank at 130, and then what's in their building code is now you actually have to have a mixed down valve. Outside of the hot water tank, you have a mixer valve that brings it down to 120 degrees, but they need that 130 in the tank to kill off the Legionella. So the next item, 1.3.9, we want to insulate the hot water lines. Now this is pretty simple. If it's it's a simple thing. It doesn't cost a lot of money to do it, and including the heat trap. And I wanted to just go through this. So what we're talking about is using just this polyurethane heating foam. It goes around the pipes. And when we talk about a heat trap, this was coming into the building code and it didn't make it in. It might make it into the next one, God only knows. But what it is it's a drop pipe heat loop. So, and what it's designed to do, it's designed to keep the heat from the hot water tank in the hot water tank, rather than it going up into the cold water supply. So again, working off the natural buoyancy of water, the hot water stays at the top, the cold water is trapped down in this little loop, and we don't get heat going up into there. It's just a little bit of an energy saver. So if you do have those in your jurisdiction, those are required in your jurisdiction, we're looking to have that insulated as well. Installing a drain water heat recovery unit on the main stack to recover heat from the shower drain. These have to be CSA certified to B55.1 and B55.2. 1 point for units less than 42% efficient, 2 points for units greater than or equal to, and an additional point if it's fully insulated. Now, drain water heat recovery, have to say, one of my favorite pieces of technology. It even looks cool. You know, there's not a lot of sexy things that we can talk about in terms of sustainability and energy efficiency. You don't go to your friends when they come over to your house and say, hey, look at my great R24 wall. It just doesn't happen. But you know what? You've got a nice piece of copper in there. It's almost like an art installation. You can show them that, and that combined with a little bit of solar, pretty much the only two cool things about energy efficiency. So these things here are fantastic. You can see from the diagram on the right, cold water enters at the bottom, it wraps itself around, and warmer water exits at the top. Now, people always think that hot water, when it comes down the pipes, it's coming down the center of the pipe. It does not come down the center of the pipe. It actually comes around the edge, and that's called the gravity film effect. So what's happening is the hot water, as you shower, think about it as you shower. You know, you've paid to heat that water. You're gonna hit it with the shower. You're gonna use that energy for about maybe less than a second. I'm a bit of a big guy. It's probably on me for a little bit more than a second, but then it just goes down a drain and it's gone. We've paid for it and now it's gone. This allows us to recover it and use it over and over and over again. And it's a simple piece of technology. They're not expensive. They're not hard to put in, and they're idiot proof. There's no maintenance on these things. And they last years, like we're talking in the order of 50 plus years of lifetime on them. And they actually, even with today's historically low natural gas prices, and if you're on electricity, it's even faster. But the payback on these things is actually, you know, it's reasonable. It's probably, you know, 15 years. So it's not something that's way far off 25, 30-year payback. It's actually got a pretty good one if you're getting something decent. Now, there's a couple of provisos that go along with this. The drain water heat recovery works best when you have all of your showers going into one stack. So on the left, we have, again, one of my clients' homes. These have back-to-back bathrooms. You can see the tubs are back-to-back. These things are sharing the same drain system. This is a perfect storm for a drain water heat recovery, because all the showers, drain water heat recoveries, I should point out, only recover energy from simultaneous water events. So the only real simultaneous water event that goes on for any length of time is a shower. It doesn't recover anything from a bath, because you fill a bath, it sits there, and then it drains. There's no water moving in and out at the same time. So a shower is pretty much where we recover it from. So we want to make sure that we're pulling it from as many showers as we can. So on the left, we have a really good way of doing this. It's a compartmentalized bathroom system. They're back to back, and they're going to use the same stack. On the right, this is another one not as good. You see here we have a shower that is easily, you know, from the scale of things, it's somewhere around 20 feet away. You are not going to be able to do that. So you have two choices. You either put in a drain water heat recovery for each unit, which is a little more expensive, or you just don't do it at all. So from an economic standpoint, the left is a far better way to go. Install an EPA or CSA certified wood stove or pellet stove with a minimum efficiency of 72 or 85. Wood stoves and pellet stoves are another way of heating. The thing I like about these, this works really well for people that do want to have that little fireplace or something like that. And the nice thing about these is I mean, there is a little bit of deforestation associated with this, but a lot of these guys buy from sustainable forests, which we talked about in our first webinar. But wood is carbon dioxide from the biosphere. So this is not pulling up anything from the lithosphere, which is down in the ground. It's in the biosphere. So it's keeping the carbon dioxide in a technical loop. So not as big a problem with the environment. And actually Canada builds some of the best pellet stoves in the world. And same with the wood stoves. We build some of the best ones out there. There's a pellet stove manufacturer in Alberta that builds some really good product. There's a couple of wood stove guys out east that are just fantastic. The next item is installing a fireplace fan kit. So here's the thing: if you're going to put in a fireplace, a gas fireplace, or even a wood fireplace, you don't want all that energy just going out the chimney or relying on a reflective, radiant piece of glass to put that into the house. Fan kits are reasonably priced, and you may as well get some of that heat out. It's just a better use of the energy. And then the last thing in this section is roughing in a properly supported wired ceiling fan and a wall-mounted switch for future installation. So what we're talking about here is a 3-wire going up to where the ceiling fan is, and a little bit of blocking to support the ceiling fan. All right, so some practical suggestions. A plate placed above grade, like I say, it opens up some really interesting layouts for your heating system. Doing a zone system, like I say, it's a little bit more money, but you do get some really good results. Consider the zone ready, and look for the next one when we do this with elite folks, because there's a system that we've kind of come up with that's zoned ready, and it doesn't cost that much. It's really cool. Installing a high efficiency sealed combustion appliance. Use that now while you can, because like I say, those points are probably going to be adjusted here in the future with the new building code. Installing heat pumps to supply the majority of space heating. Installing a programmable thermostat. We all pretty much use programmable thermostats. Just spend the extra couple of dollars, get one that will have the setbacks, and get one that has filter changing. You know, we're talking difference of maybe $10 or $15, and you can get extra points within the Built Green program. Install an HVAC appliance with a variable speed fan. Now, variable speed versus multi-speed, like I say, the variable speed will use a little bit less electricity. And then all mechanical systems designed through a certified mechanical designer. Although the mechanical design may cost you some money, you're going to save some money on the sizing of your appliances. So it may not be a total wash, but you will get a little bit of savings from the size of your mechanical, and you will have a much happier customer, less callbacks for your warranty department for cold rooms, or I'm not getting enough heat here, not enough heat there. Properly designed, these things work really, really well. I know we're running horribly late. I apologize for that. It's 3:12. I'm just going to quickly run through, and when I say quickly, I mean probably for the next 20 minutes or so. We're going to talk a little bit about the on-site generation. We're going to talk about solar heating and solar hot water and solar panels. So on-site generation is production of energy at the point of use. So on the site to which is being consumed. We're not talking about anything off-site. We're not talking about solar farms. Again, if you guys want to check out that Drake Landing, it might actually qualify for on-site. We might let that one go because it is all kept in a tight technical loop. And in some cases, the surplus energy makes it makes it back to the grid can be sold. So the first section is the home is built solar ready, following the guidelines from NRCan or the Canadian Solar Industries Association, or we go full on and we install an active solar hot water system, and then you get points for the amount of domestic hot water load, or we can install a PV system sized for 20, 30, 50, or 80% of the solar load. Now I have to say, solar, other than that drain water hot recovery that we just talked about, pretty much the only really sexy part of energy, of the whole energy and sustainability side. So it is kind of a thing. It does show off to the neighbors that you care. So let's talk a little bit about that. So this here is a site. Again, when we publish this, you can click on this. You can go to NRCan and actually download the Solar Ready guidelines. So these are the guidelines, and we make a separation in Built Green. If I go back to it here, this one was built solar ready, one for domestic hot water and one for photovoltaic, because depending on where you are in the country, solar PV sometimes makes sense and sometimes it doesn't. Solar domestic hot water sometimes makes sense and sometimes it doesn't. So you actually have to do a little bit of studying up on it. And again, some of the EAs out there know what I'm talking about, and they can help you out on that sort of thing. This is what I call a solar, this is kind of the solar map of Canada. There's many out there. This is just one that I pulled off the internet. And this indicates what we call solar insolation. So this is the amount of kilowatts, and this is for solar electricity. Solar PV or solar domestic hot water is something a little different. But as you can see here, Canada, we do quite well. There's some great areas down in southern Alberta and southern Saskatchewan do really, really well. The green areas and the blue areas are probably not some places where we want to be doing a whole lot of it. But you know, with solar coming down in price the way it has, it almost pays to have solar anywhere in Canada now. It's absolutely fantastic. If I think about, you know, the first solar, the first net zero home that I was involved with was just, you know, I think 2012 was the first year we did it. The solar cost for installation was absolutely unreal. The last one I built, which was 3 years ago, that cost was about half. And I think it's gone down a little bit even since then. So even in the green areas now, the blue areas I'd probably still stay away from, but in the green areas now, it's actually worth it now to do solar. And then, sorry, and in the other areas, it's absolutely worth it. This is kind of an overall. This is an average of how many kilowatt hours you can generate per kilowatt of solar installed. So if we look at Saskatchewan, for 1 kilowatt, which is typically about 3 to 4 panels, depending on what kind of panels you have. So from that one, you can generate 1,330 kilowatt hours per year, and that's an average. If you have a very rainy year, if you have a very sunny year, it's going to vary. And this is based off of the last 25 years of data. So when we're talking about solar ready, we want to make sure that we have a minimum roof space allocation, unobstructed roof area. So we don't want to be installing solar on where they're going to be impeded by chimneys, vents, skylights, other protrusions. And the optimal orientation, of course, is south. But again, like I say, with solar being as inexpensive as it is, there's guys, even in my area of Alberta, there's guys putting them on northwest and northeast, and they're still getting a reasonably good return on it. So so you can see here, it even says the orientations from east to west. The optimal solar collector angle is equal to the site latitude. So the further you are north, the steeper we want the pitch of your roof to be to maximize on that. Now, it's not this is not a make or break kind of a thing. The difference between an 8-12 pitch and a 12-12 pitch on a home in terms of solar generation is actually pretty small. But again, if you're going to optimize it, we want it to be the same degree on your roof as the angle of, or as the degrees of latitude. So again, what we want to do is we have the roof space. Again, for solar ready, we want to have two conduits, two 3-inch conduits for solar domestic hot water. These should not have elbows, okay? Because we're running plumbing line through them. It doesn't handle corners all that well. Now, when we run into the solar PV, it's a 1-inch conduit because all we're doing is running an electrical line down there, and that can have as many elbows as you like, because the current doesn't recognize corners. In the attic, we want to make sure that the rough ends are capped, and we want to make sure that we have at least 18 inches between the top of the bottom of the roof deck and the top of the cap. And we also want to make sure that these things terminate well above the attic insulation so that they're easy to find. And you know, in areas, you know, as insulation become like currently, you know, we have to have R40 or R60 wherever you are. If you want to make it high enough so that if somebody adds another R20 to it, they're not going to lose their solar rough ends. So we want it properly sealed around the attic penetrations, and again, that's to keep the air from coming in through the interior walls. And again, in the basement, we want these things sold. Now, I should point out, in the pipe itself, we do want to have some insulation. Okay, we don't want this thing to, because we don't want this to be a cold conduit, because the cold air will drop. And again, here we want to have these things capped off. They're sealed around the mechanical room penetrations and capped to maintain the home fire rating. It's also to keep air from becoming an air conduit. And connections to an existing. So again, I don't want to go into too much detail on this. These are just some details. Again, when we post this is all in the guide. So when you download it, this is all in the guide. But there's different ways that you can hook up your solar domestic hot water system, and that is to an existing hot water heater. You can hook it up to an instantaneous or a boiler system. You can hook it up to a solar tank, its own solar tank, and this is a fairly common one here, where they have a separate tank just for the solar domestic hot water, and then they'll have a separate hot water tank for the non-solar domestic hot water. This is probably the most common, and it's got a drain back reservoir to it as well to keep things from freezing. Okay, the next thing in here is we want to talk about the home is built ready for plug-in vehicles. 1 point for 240 in the vehicle parking area, 2 points for certified charging station. So electric vehicles, wave of the future, let's be real. So we recognize this in our program, and we're giving the builder points for putting this in. We actually have a couple of builders that are already doing it on a regular basis. They're doing the rough, and they're not putting in the certified charging station. As we move forward, you know, we do have to look at this from a land development standpoint, because if we have every home has a charging station, we are going to have to look at doing some charging timings and things like that, so that we don't blow transformers in areas. So on-site generation practical suggestions. Now, when I'm saying practical suggestions, none of these are going to be inexpensive. The Solar Ready is. Solar Ready is dirt cheap, and you're saving hundreds, maybe thousands of dollars for the homeowner in terms of future-proofing the home, especially for solar domestic hot water. Because if you have to run that afterwards, you're going to make an absolute mess. You're going to be tearing apart drywall to run these lines and stuff, and it's just not going to be pretty. At rough-in stage, plumber can run these things super easy, and it makes it super simple. So consider that. You know, it's not the worst thing in the world. Consider also just Solar Ready in some areas where the solar domestic hot water isn't necessarily applicable. Consider just running the conduit for the electricity. The reality is, at some point in time, somebody's going to run solar PV. It's just going to happen. It's a death and taxes kind of conversation. So if you as a builder, you put it up there and they go up there and lo and behold, it's there, you've just saved that customer a boatload of money. Installing the active solar hot water system, the PV generation. Like I say, the PV has come down in price so much that it is practical for use just about anywhere except those blue areas we were talking about. And then the roughing in. It's a 240 volt plug in your garage. That 240 volt plug can also be used, you know, if the guy's a welder, he can plug an arc welder in there or something like that. But you know, the intention here is to actually run it for a charging station. Okay, some tips, and I promise we'll be brief. Practice conscious purchasing focused on sustainability. If you're unsure, ask. It's not embarrassing to have the conversation. Buying local is always a better idea, particularly in these times. This is very important. Look for third-party certifications on materials. Just because somebody says it's efficient doesn't necessarily mean it is. You want to look for that third-party certification, Energy Star rating. You want to look at something from CanMed Energy. Actually has a really good site for where they've rated all these different and the energy efficiency of different products. Keeping an open mind to new ways of doing things, like we talked about. You know, talking about. You know, a lot of people, they don't really want to get into the heat pump stuff because they've never used it before. Don't be afraid of the technology. 10 years ago, I would have said, yeah, there's some technologies you need to be afraid of, but those technologies have really come to the fore, and they're pretty much bulletproof now. And don't get cornered into paying something more for green. Now, on the energy efficiency side, you are going to pay more. Hate to tell you. But on the rest of the stuff within the Built Green program, buying sustainable lumber versus non-sustainable lumber, lumber's a commodity. It's all the same price. Buying something that has an indoor air quality rating on it versus something that doesn't, probably the same price. So don't get cornered into paying for something green. We'd like to just do a quick shout out to our Built Green product catalog. If you're looking for something and you're interested in something within our program, say you're looking at insulated concrete forms, you can go to our product catalog and you can actually see whose forms that our technical committee has vetted, and they will get you the points within that program. So these are actually intended to help builders save time with their sourcing, and they'll help you earn points towards your certification. A lens on energy performance. We've seen this before. Energy is only a part of building sustainably. It's the biggest one right now. It's the number one with the carbon reduction and stuff. That's the number one cause. But we can't lose sight of building energy efficiently and building a toxic environment or something like that. Materials and methods, like we talked about in our first session, they actually help with thermal performance and contribute to energy code requirements. Building tighter is a benefit, but without a holistic approach, issues arise. We can build really, really tight, but if we're not taking all the chemicals out, we're actually poisoning our food stock. Incremental improvement in 7 critical components of responsible building. Those are on the right-hand side there. So that's what Built Green's looking for. We're not looking for you to hit a home run the first time out. No, we just want you to get on base. Bunt it. It's okay. We'll grow with you. Waste is on the radar of municipalities across the country. Increasingly, water conservation is too. And good choices shouldn't cost you. Like we say, we offer practical, affordable solutions. It shouldn't cost you, like I say, other than the energy side, shouldn't cost you a lot more to do something green. So when we talk about checking all the boxes, when we look at the energy step code, it ticks one box. The energy code, the step codes, 936, they're dealing with just one thing. With Built Green, you're dealing with 7, a very holistic approach to sustainable building. Business case, the economic benefits, like we talked about, the rebates that are available. Again, just to reiterate, every Built Green home qualifies for a 15% rebate from the mortgage insurers. So if your clients put less than 20% down, with a Built Green certification, they will get 15% of whatever they paid back. It's a nice thing. I mean, when I was working for a home builder, we used it as kind of a final thing. We gave it to our salespeople. Salespeople would call up the clients. We would actually have the salespeople apply with the clients, because the cool thing is, one is it's a great day for the salesperson because they are that person's favorite person that day because they just got them, anywhere between $1,000, in some cases $2,000 back. You're always really happy with somebody who gives you money. And also, it was a great way for the salesperson, if they were good, it was also a great way for them to mine for new customers. Well, we got you $2,000 back. Do you know anybody else who would like to get $2,000 back when they're building their new home? We just pass along benefits to the home buyer, utility savings, obviously, but fewer fix-its, increased value. Generally speaking, the products that we promote through our program tend to be a little bit higher in quality. They have a longer shelf life. It's better for the consumer. There is a consumer demand out there. All things being equal, a consumer will pick a sustainably built house over one that isn't. So if you have a Built Green seal to go along with your program, then you and your competitor doesn't, you win. And that's great for your brand. And I don't think we need to go into any of that. So, hey, look at that. We have, I'm going to introduce Karen from Built Green. She's going to unmute herself. And we have some draws.
Yes. Can you see and hear me, Dave?
I can see and hear you. I'm hoping everybody else can too.
Okay. Yeah, so I am Karen Podolsky. I'm also part of the Built Green team. We do have a few product giveaways. As Dave mentioned, Built Green Canada offers a product catalog of materials that can help earn points towards Built Green Home certification. So we have 3 prizes from our catalog, each valued at around $400, thanks to Henry Company, Vancouver ICF, and Eco Innovation Technologies, all of whom have product listings with us. So following this webinar's focus on energy and envelope, these products can help earn points in that section of our programs. First up is a roll of Henry Company's Blueskin VP100 air barrier system, and the winner is Nella Quintero from Sunset Homes in Alberta. Our second prize is for a $400 gift certificate for Vancouver ICF's Nudura insulated concrete form. And the winner is Harp Chima from Asante Developments in BC. And our third product giveaway is an Eco Innovation Thermodrain unit, which is a drain water heat recovery unit. And the winner is Harminder Danova from Jasmine Construction in BC. Congratulations to all 3 of you. We will follow up with you afterwards so you can collect your prizes. And thanks to Henry Company, Vancouver ICF, and Eco Innovation Technologies for these prizes. Dave, back to you.
Thanks, Karen. All right, I just want to get into the Zoom chat here a little bit. Now, for all intents and purposes, we're kind of finished. I just do want to say, in closing, we went through an awful lot of things. This has been recorded, so we are going to be able to post it up in our builder section, so members will have access to it. If you have any further questions, you can actually get a hold of us toll free. There's the number up there, or through Built Green Canada. I actually don't work in the office, but if you have a technical question, you can reach me through Built Green Canada. They send me an email, and I try to be as quick as I can to respond. With that, I thank you all. For anybody who has to go now, I've taken up an hour and a half of your valuable time. I hope it was worth it. And I'll just go through the Zoom chat and just kind of address some of these things. So for those of you who want to stay and listen to what other people had to say about it, you're more than welcome. So let's just begin. Okay, most homes have an open plan. How zoning will be beneficial for the main floor and the second floor. Even though we have an open plan, your second floor may be an open plan, but your top floor is usually fairly closed. And ideally, we'd want to have your basement fairly closed. What we can get, and I use my house as a shining example, is I have an open to below area in my front entryway. These tend to be a giant chimney, but the bedrooms are completely shut off. So I would benefit from having zoning in my zoning control in my master, because my master tends to be the coldest room in the house. It's the furthest away from my furnace. The main floor here, my main floor is actually fairly open, but depending on where you're at, I mean, if you think about it, some people on a cold night, they'll put a fireplace on in their family room. Why? Because they want it a little bit warm there, and the fireplace warms up that area. It'll also throw off your thermostat too if the thermostat's too close. But a zone system is inevitably going to be better than a non-zone system, even in an open area. Because again, like I say, open area is usually restricted to the main floor, tends to be open. Upstairs tend to be a little more segmented. Basements tend to be a little more segmented. To clarify, did you say slab on grade does not qualify for the mechanical placed above grade? A slab on grade would not. Simply because in the case of any kind of flooding, slab on grade is ineffective. Now, for those that are building on a foundation, a main floor would still work because you're usually a couple of, 2 feet above grade. So they're gonna fill up the basement first, and then it'll come. So you're gonna buy a little bit of grace there. But a slab on grade does not qualify for mechanical placed above grade. That is mechanical placed on grade. Can you comment on? We did that. Yes, we are sharing the slides afterwards. I think I mentioned that. One day we'll have to put environment first, not the pocketbook. And coal-fired or oil-fired electricity is no better. Carbon-based sources have to end. Yes, couldn't agree more, but we're stuck with them for the foreseeable future, so we still have to manage within that. What about, bioethanol fireplaces? I haven't heard of this stuff for a long time. Yeah, I mean, any kind of biofuel is good. Because again, you're creating fuel from and keeping it in a closed technical loop. So it's a biofuel. It comes from the fuel source is within the biosphere, hence the name biofuel. So it's always a better way to use as a heat source or as any kind of a fuel source. You're always better to use something that's within the biosphere rather than something that comes from the lithosphere, which is the ground. Drain water hot recovery. What would be the maximum time between shower cycles in your home to still get energy savings? That doesn't matter. If you're doing a shower, it's simultaneous. As it's going down, it's coming back up. One of the things I didn't mention when we were talking about drain water heat recovery, to kind of tweak it up just a little bit, you can actually have your drain water heat recovery come off as a Y. Some go into your hot water device, and some go to the cold side of your shower. That actually increases your efficiency a couple of points. But there's no maximum time between shower cycles in the home to get the energy savings. It's a constant thing. Does the drain water heat recovery passive transfer colder temperatures? Does the drain water heat recovery passively transfer colder temperatures and reduce the efficiency of the hot water heater? Actually, when the homeowner takes cold showers, it uses the cold water in general out of the connected showers. If you're using cold water, there's the drain water heat recovery is just there. The cold water is just going down. There's no water going into your hot water device, so there's no chance of recovery. So it's not actually putting cold water in there. And somebody actually answered that. Thank you, Maran. It is better to install as close as possible to the shower. Absolutely. The temperature loss is not enough to avoid installing at the closer preferable. Thank you. Hey, we got lots of thanks. We better do good to designate 2 hours for this presentation. I agree. I felt a little bit rushed. All right, that's it for everybody. I thank you all very much. There's 58 stalwart people. I appreciate you sticking around. You guys have yourself a wonderful day, and we will talk to you hopefully next month with this part 2 of section 1.